Hello everyone, this video is about the graph, domain, and range of an exponential function. Okay, so for this type of question, you have to graph it. Okay, after that, find the domain and the range using interval notation. Okay, so I would recommend everyone to use the Alex calculator to do this type of question. Okay, so let's do that. So first of all, I'm going to draw a table for this. Right? I'm trying to figure out the x's and the y's. I need some points for me to graph it. Right? So I'm going to start with x, and this is my y. So when my x is equal to, let's say my x is equal to 2. Okay. I picked 2 on purpose because when I put 2 in here, 2 minus 2 gives me 0. Right? So whatever number to the power of 0 is 1. Okay, so when my x is equal to 2, my y is equal to 1. Okay, so let me pick another one. Let's say if x is equal to 3. Right? I picked 3 on purpose because 3 minus 2 gives me 1. 4 to the power of 1 is just 4. Right? So when you guys have other equations, the numbers that you choose for x, it's quite, you guys need to choose the values for x. Think about how is it going to help you, right? And let's say today I choose x is equal to 4. Okay, so 4 minus 2 I have 2. 4, that means 4 minus 2 I have 2, and 4 to the power of 2 I have 16. Right, so now I have 3 points. I can use the buttons that you have on Alex, that where you guys just put in the coordinates and Alex will do it for you. Just put in these points and you should be able to put the points in. Okay, just put the points in. After, that's the first step. So figure out the table, figure out the points, and put the points in. And the second step is you need to draw the asymptote. Right, asymptote. Let me show you guys how the graph looks like. So when x is equal to 2, my y is 1. Right? When x is equal to, my y is 1. Okay, x is equal to 2, my y is 1. That's correct there, this point. When my x is equal to 3, my y is 4, right there. Right? So I got these 2 points. When my x is equal to 4, I have y is equal to 16. As you can see, we only have up to 9. Right? So it is out of the range. So that's why I said we need to choose the values of x smartly. Okay, that's out of the range. So we that's not really helpful. But fortunately, we only need 2 points. Right? So after you put in that point, after you put in these 2 points, the next thing that you should draw is the asymptote. In this case, our asymptote is here. That's your asymptote. Okay, I'm assuming that. I'm assuming that you guys have read what asymptotes are. Asymptote, I think that's how you spell it. Asymptote, I think. Okay. Sorry if I misspelled it, but this dotted line, that's the line that you have to draw. Okay. So after you plot in these 2 points, draw the asymptotes. For an exponential function, we will always have the horizontal asymptote on the x-axis, alright, on the x-axis, unless the function unless we have some okay, there are special situations where the asymptotes will be moved maybe up or down. Okay, depending on the equation that they give us. I will make another video talking about that type of question later. Okay. But for this question, since we are only playing with the x, right? What we are doing here is we're minus 2 from the x, so we're not playing with y, which means the asymptote is not going to go up or down. It stays right there. Okay, so your asymptote is here. So I've put in the 2 points, draw the asymptote on the x-axis, and Alex will draw the line for you, and you're done. Okay. the second part of the question is asking you guys to find the domain and range, right? So basically, domain is this: where can x be? Okay, so where can your axis be? And range is your where range is where can y be. Okay, so let's start with domain. I'm going to bring that graph up. Okay, let's bring it up. Alright, so we have this graph right there. X, is there a limit where x can be? X can go as far, okay, x can go as far as we want, right? Any number, so positive infinity, right? And x can also go to the left as far as we want, right? Negative infinity. So basically, that's your domain. Okay, your domain is negative infinity to infinity. Okay, because x can be 100, x can be 1000, x can be 10 million, right? And we just put in those values and we can get our y. Or x could be negative 10, negative 100, or negative 99, whatever. So x can also be whatever number we want. So x is basically the whole axis. That's your domain. Okay. For range. Okay, so now let's look at the range. Let's figure out what's the maximum number is going to be. Okay. As you can see here, if I move across the graph from the left to the right, this blue line keeps on increasing, right? So is there a limit where this line is going to stop? No, right? Because this line can keep on going if x keeps on going this way. As x goes to the right, our y will just keep on going, right? So the range is also positive infinity. Okay, for the range, the upper boundary is also positive infinity. However, what's the lower boundary? If you look at the line, as we go to the left, it slowly goes down and then slowly goes down, and as you can see, it becomes closer and closer to the x-axis, right? Becomes closer and closer to the x-axis. But remember, the asymptote is right here, right? So which means the line will never touch the y equals to 0. Asymptote is on the x-axis, right? So the equation is y is equal to 0. So even though this line, as we go to the left, this line will approach to y equals to 0, but it can never touch it. This line can never touch the asymptote. So which means 0 is our lower boundary for the range. Okay. So if you go up, you can go all the way up to infinity. If you go down, you cannot be 0 because the asymptote is right there, right? That's what's so special about the asymptote. Okay, so your asymptote would be your lower boundary, and look at the graph, you can figure out what's the upper boundary for the range. All right. So this is the video where we're not going to move the asymptote. I'll make another video where the asymptote is not on the x-axis anymore. Okay. All right. See you guys in the next video.